Hello everyone, you are welcome to another video session of Python for All. This video is a continuation of our last video, which is on Python data structure. So this is a part 2 of Python data structure. Here we will continue by discussing the subject slicing, and thereafter we'll look at list comprehension, dictionary comprehension, generator expressions, and an alternative tuple comprehension. Let's start with slicing. Slicing is a way to extract a portion of a sequence, starting at a specific index and ending at another specific index. You can also use slicing to access a subset of elements in a sequence. Let's take this example. Here I have a list of numbers 1 to 5. I want to get the last element of this list, so I simply access it by printing numbers of -1. We said earlier in our previous video that -1 can be used to access the last element of a list. If I run this cell, what do I have? It gives me 5. If you look at the list of numbers, 5 is actually the last element in that list. Also, I can get the length of the elements in this list. In other words, I can find the total number of elements in that list. How do I do that? I simply print length of numbers. Okay. Likewise, I want to find here also print the first element of that number. So first, let me first of all get the total element in numbers. So I create an empty cell here and then print this. If I run this cell, you see the total number of elements in numbers is 5. And if you count it, it's 5. It starts from 0 until 4. Indexing starts from 0, 0, 1, 2, 3, 4, but the total number is 5. Next, let's access the first element in that list, which is numbers. If I run this cell, the first element is 1. Now, next, let's access the first 3 elements. Okay, you can write it this way. Oftentimes, you can write it this way 0 to 3. Okay, you start from the first element until the third. If I run this cell, the first 3 elements is 1, 2, 3. Likewise, you can access this also by simply omitting the 0 and starting with a colon until the position or the index you want to stop, which is your stopping index. If I run this again, it gives me same result 1, 2, 3. Now, lastly, let's access the last 2 elements of that list. So if the last element is -1, the second to the last is -2, the last 3 starts from -3. So I access it by saying print numbers, open a square bracket. Like we said earlier, Python indexing is accessed using the square bracket. We start from -3 until, if you put until -1, it will give you the last 2. But if you remove that, if you put no number, just leave it, put a colon, it means until the end of that list. If I run this cell, what do I have? 3, 4, 5. So 3, 4, 5 is the last 3 elements. Sorry, I meant to say here the last 3 elements, not last 2. The last 3 elements of that list. If you want the last 2, you start from -2 until the end. So the last 3 is 3, 4, 5. Next, let's talk about the concept of list comprehension. List comprehension is a concise way to create a list from an iterable. It is a syntactic construct that allows you to create a list based on the elements of an existing list, tuple, or string. It can be used to create a list of any length and with any kind of element, any kind, heterogeneous, any kind of element. It is a very powerful tool that can be used to simplify your code and make it more concise. It can enhance readability, and in some cases, it will also make it difficult to find bugs. So you should know when to use list comprehension and when not to use list comprehension. We'll see that in our future videos, especially when we get into functions. You'll see the applications of how we use list comprehension. Now, the syntax for list comprehension is as follows. You have the variable new list equals to, you open a square bracket, and then you have the expression for element in iterable. An iterable is simply a sequence or an object or container that can be looked through. Okay, so we'll see there are a lot of them. A list is an iterable, strings are, tuples are, dictionaries are, and as we have many of them. Okay, we'll be seeing them. So anything you can look through, you can iterate through, you can look through is simply an iterable. So here we have squares. I want to create a list of squares. Now, instead of using a for loop, which I can use to do that, okay, I create an empty list, loop through the range of numbers that I want to create the squares, and then append it to the list. That's one way of doing it. But if you actually, during our practical coding section, I will show you how we can profile this and see which of them is memory efficient, the one that runs faster, and that will also inform us on the usage of list comprehension and for loops. We are still going there. Okay, in our live session tomorrow, which is on Saturday, 12th of August, we'll discuss all these things and demonstrate them practically, and you see how these things affect the memory efficiency of your code. So here I have squares, open a square bracket, and of course I want to have squares of numbers within the range of 1 and 20. So to do that, you put in the expression. The expression is what? X squared for x in range, okay, starting from 1 until 20. So because the way Python indexing is, it starts from 0 until n. So now we want to look a range between the range function itself, okay, stops at the range function stops at n minus 1. So if I want a range of number between 1 and 20, I should stop at n minus 1, which is 20 minus 1, 1 and 20. So just put that as a list. In the list there, write the expression and then run this for loop inside. If you run this cell and you see what we have, if we print the squares, what do we have? You see we have the squares of number from 1 until 20. 20 square is 400. That's a list comprehension. Now, there is this term that people often called tuple comprehension. Actually, there is no equivalent, no word as such as tuple comprehension. What we have is a generator expression, but we can also use a generator expression to mimic a tuple comprehension, okay, by calling a tuple on the generator expression. I would explain that here. So there is no tuple comprehension in Python, but it can be implemented by calling tuple, which is a function in Python, a built-in function in Python, on a generator expression. What a generator expression does is that it simply yields what? An iterable for you. Okay. Now, the syntax for generator expression is as follows. We have new expression and then open parentheses, expression for elements in iterable. While we can syntactically write tuple comprehension as new tuple, and then we call a tuple on a generator expression. Let's see an example of this in this next cell. Here I have cubes and I have x cubed for x in range. I want to look for cubes of number between 1 and 10. If I run this cell, what do I have? I'm printing cubes. If I run this cell, oh, look at the output. He gives us a generator object. Okay, what it means is that here we can access the content of this cube is a generator expression. You see, this generator expression is a very, very vital way of managing the memory of your system efficiently. I use this a lot when I handle large volume of images in hundreds of thousands of them. Instead of lumping them into a list and eating up the whole memory of my processor, all I simply do is to lump them into a generated expression. And as when needed, I access them. We call that, there's a term, we will call that in Python, we'll call that lazy iterable. Okay, so that's what the generated expression is. You have it, coded in and saved onto that memory in bytecode, and then you can access it. So to access every element in cube, I just simply loop through it. So I can call for cube in cubes, print cube, and let's see what it gives us if you run this cell. If you run it gives us the cubes of all the numbers in cubes. You can also use the next function, okay, built-in function in Python to access every element in that cube. We'll look at that in our next two videos. We'll look at those built-in function next, how we can use them on generator expressions. And we'll also look at generator expressions in proper when we get to Python functions. We'll see how we can write generator expressions, not just as uh, in condensed form this way, but we'll see how we can write them in functions and use them effectively. I've used it quite a number of times to save memory and make my code run faster. So next, let's look at now here. I want to mimic the generated expression to form what we can call tuple comprehension, but actually there's no such word like that in Python. So here I have squares, but I'll call the tuple function on the generated expression x squared for x in range 10. Now I'm starting from 0 until 10. So if I run this cell, what do I have? It prints for me 0 until 9. 0 square is 0, 1 square is 1 until 9. If I wanted it until 10, I just put the range 11. If I run this cell again, what it gives me? It gives me the squares of numbers between 0 until 10, which is 100. So because I've called a tuple function on the generator expression itself, it gives me a tuple. So that's how you can mimic tuple comprehension in Python, by calling a tuple function on a generator expression. I think you understand that. Let's move to the last for today, which is dictionary comprehension. This is a concise way to create a dictionary from an iterable. It is a syntactic construct that allows you to create a dictionary based on the element of an existing list, tuple, or strings. The syntax for dictionary comprehension is as follows. We have new dic, and then we open a brace bracket. We have the key, put a colon, the value. For key value, you have to put the key value in that parenthesis in the iterable. Let's see an example of this. Here I want to create squares of number and map those squares of number to the number. In other words, if I have one square, what is it? Map it as a key to the value of one square. 2, map it to the value of 2 squares, like that. So here I have x. For x square, now the key is x, which is the item. Okay, for x square, in x key, x square value for x in range 1 to 10. If I run this and print squares, what do I have? I have a dictionary with mapping the numbers to their squares. So 1 square is 1, 2 is 4, 3 is 9, until 10. This is what we refer to as dictionary comprehension. Now, we can also append to an empty dictionary. You can create an empty dictionary, loop through your variables, your objects, your strings, your list, and append it to a dictionary. Now, here I have a list of courses. The number of elements is 7. I have grades, also 7. I want to create a dictionary mapping the courses, okay, as keys to their respective grades. Now, the wrong way of doing it is to simply create an empty dictionary with key courses and the value is an empty list. Grade, the value is an empty list. Then I run a loop for course in courses, append student of course, append, so for every course, append the course to it. And I run a loop for grade in grades, append. Now, let's see what this will give us by printing the student dictionary. And then you understand, first you need to run this first cell. So I run this cell and then run this cell. You see what I have here? You have find the courses are appended rightly, but you now have in the second loop, you have the grades appended for each time you append the course to the list. That's why it's wrong. The best way of solving this problem, there are so many other ways of doing it, but an efficient way of doing this, which is a correct way, is using the zip function. We will also look at these built-in functions in our next videos. The zip, the filter function, the map function. These functions help you to write more Pythonic codes and efficient codes. Okay. So here also we instantiate the empty dictionary, course with empty list, grade as item with empty list. Then next, we simply loop for course and grade, because for every course you have a corresponding grade. So say for course in grade, put it in parentheses in zip courses and grades. Now, if a course is found, is present, right? Append student of course, append it to course. Get out of that if conditional statement and append grade. So that was happening here. If and append grade. There are very many ways of doing this. You can also use a continuous statement, but I don't want to use the continuous statement and the break statement until we get to control flows in Python, where we talk about the for loop, the while loop, and the if conditional statement. Then we'll begin to see all the expected statements that we can use. So here I'm just trying to show you do a simple demonstration. So if I run this cell again and print students, what do I have? You see, I have courses, I have the grades correspondingly mapped properly. Now, you can loop through dictionaries in two ways. The first way is looping through the key and value pair in the dictionary item. So here I loop through this dictionary and I save the result as a tuple of key and value pair in a list. So I instantiate an empty list and I say for key value in this dicts.items, append the key and value as a tuple to the new list. If you run this cell, let's run this cell. What do we have? You see, it tells you key 1, value 1, key 2. Another way of doing this is to use the list comprehension. So here you have your dictionary, and then you create your list variable and immediately assign it to perform your list comprehension right in that line. So I open a square bracket and say key value pair, give me a tuple of key and value for key and value in dicts.item. If I run this again, you see it gives us same result. In our next video, we will look at the memory efficiency of these various methods. First, we check how fast each of them are, which one is faster and which one is slower. Then that tells you, helps you to make informed decision on which to use when you are trying to optimize your code or profile your code. With this, we have come to the end of this video. I will leave this notebook as a link in the description section, so you can download this notebook with that link. If you have any questions to ask, please put it in the comment section. Also, like this video, share this video. And if you are watching this video and you have not subscribed to my channel, please subscribe to my channel. And when you subscribe, don't forget to hit the notification bell in order to get notified of my new uploads. Till we see then, have a wonderful day.